IM3 Honors 4-7 Extra Practice Solutions on Solving Systems of Inequalities. This one's got a puzzle that goes with it, so let's take a look at that. So here's the puzzle that goes with that extra practice. We're trying to solve the riddle, what did a toothless old termite say when he entered a tavern? And to solve this riddle, we have to solve these 6 systems of inequalities. Now the idea is when we actually get the solution set, which is the shading or cross-hatching, it should cover one of these 3 words. And we just put those letters wherever the numbers are down here that correspond with the problem. So for example, if I do number 1 and this TOO is in my solution area, then I would put a TOO next to the ones. I don't know if that is the answer, but that's how this works. Let's give it a shot. Okay, here we go with problem number 1. These are all inequalities that are linear, so we're going to be using line sort of math in doing these. So particularly getting the slope-intercept form and then using the slope and the y-intercept to graph these. So for this first one, y less than or equal to x minus 1, we have a y-intercept here of -1. Since I have an equals under my inequality, I have a solid line and therefore solid dots. So I'm putting a solid dot at -1 on the y-axis. And then this x means we have a 1x there. So that's a slope of 1 over 1. So up 1, right 1. And let's draw a solid line through those. And now since this is less than, we're going to shade below. So everything underneath that line is part of this particular part of the inequality system. Now this next one, y greater than or equal to -3. Since there's no x here, this is a horizontal line where the y value is always -3. And we have the equals. So we're going to have a solid line going through y equals -3. So down here. And since this is greater than, we're shading above that line. So we're going to go up here. And now we just look for where those shadings overlap. And that's this triangular area right here. The only word included in that is the word end, or the letters end, I guess. So we're going to put those in the 1 spots over here. So END. Problem that we're trying to figure out with some graphs. Now this one's a little interesting. We have x less than or equal to 2. So since we have x and no y involved, this is a vertical line. If x is always the same value, x is always 2 in this case, we have a vertical line going through 2. Since we have the equals still, that's going to be a solid vertical line going through 2. And since it says less than, x less than means we're going in the less than direction for the horizontal, so we're going left, more negative. So that's everything to the left here that we're shading. Now for the next one, 2/3 x minus 1, this is just more of a traditional y equals mx plus b1. We still have the equals, so we're still using solid dots and solid lines. Y-intercept of -1 right there. And then slope is 2/3, so that means we're going up 2, right 3. Another dot there, solid line through those. Less than means shade lower than. Since it's y less than, we shade lower. So that's everything underneath. And then this overlapping region here matches up with the letters ERE. So that's going in the 3 2 spots over here. So we've got ERE. Problem number 3, we've got a difference from the last 2 problems in that in the inequalities we have no equals. This is less than no equals, greater than no equals. So we're going to use open dots and dashed lines for both of these. So for the first one, we have a y-intercept of 1. So right there, open dot there. Slope of -1. So from that dot, we're going down 1, right 1. Draw a dashed line through those. And since it's less than, we're shading below, so everything underneath this line. Next up, this one we have a y-intercept of -2, that's right there. And slope of 1/2, so we're going up 1, right 2. Dashed line through those. It says greater than, y greater than, so we're shading above. So that's everything over that dashed blue line. And then our overlapping region in here, this is going to match up with HEB. So that's going in spot 3, HEB. And on to the next. For this problem, we have an interesting new setup, this 3x plus 2y greater than 4. So that's not in slope-intercept form. We're going to have to fix that in a bit. But first, let's deal with this y less than x. So this is just a line going through the origin. We have an invisible plus 0 for the y-intercept, slope of 1, and there's no equals, so we have open dots. So there we go, open dot on the origin. And then we're going up 1, right 1, and then dashed line through those. Less than means lower than, so shade down. So that's that. Now let's go ahead and take a look at this next one. I'm going to have to rearrange this one to get it in a form that I can actually graph. Let me start by subtracting 3x. We're basically going to get y by itself is what we're doing here. So subtract 3x from both sides. And now I have to also divide by 2. So we have y greater than negative 3 halves x plus 4 divided by 2 gives me 2. Open dot on this because I have no equals. So we have a y-intercept of 2 up here. Slope of negative 3 over 2. So from our y-intercept we're going down 2, or down 3 rather, right 2, and draw that dashed line. We have greater than, so that's shading above. So that's everything above that blue line. And then the intersection between those two shadings right here, that gives us IST. So that's going in spot 4 at the beginning here. So IST. For this next one, the very first inequality needs to be rearranged, and there's a little curveball that they threw on this one. You'll see what it is in a sec. So getting y by itself, let's start by subtracting x from both sides. So negative x plus 12 on the right side. And we also have to divide by negative 3. So that'll give us y on the left. And we have to be careful here. So this is going to be negative 1 over negative 3. So positive 1/3 x, that's fine. But when we divide or multiply by a negative, the inequality sign reverses direction. So this less than or equal to is now becoming a greater than or equal to. And again, we have negative over negative gives us a positive 1 over 3. And then finally, 12 over negative 3, that's negative 4. We have equals on this, so we have solid lines and dots. Y-intercept is negative 4, solid dot down there. Slope is 1 over 3, so we're going up 1, right 3 from that y-intercept. Solid line. And after reversing our inequality, we have greater than, so now we're shading above, not below. So that's everything above that line. Next up, x greater than 2. That's kind of like the problem in number 2 where you had a vertical line, and it's actually going through the same place, going through x equals 2. Since there's no equals, this is going to be a dashed line going through there. And we have greater than. That means when you're talking about x values, we shade to the right. So that's everything over here. So that means that ERH is in our overlapping final solution area. So we're putting that in spot 5, ERH. Here we go now with our final problem. Only 3 more blanks to fill in. So our first line here, we've got y less than or equal to 1. That's a horizontal line through y equals 1. And it's a solid dot or solid line because we have the equals. Less than means shade below when we're talking about y's, so down here. Next up, we have to rearrange the second one to put it in mx plus b form, which I can do very quickly by just subtracting the 2x from both sides. That's everything I need to do on that front. No equals, so I have open dots, open lines, dashed line, y-intercept of 1, so that's right there. Slope of negative 2, so down 2, right 1, draw the dashed line. And less than means lower than, so shade below, down here. Here's our overlapping region, this trapezoidal area. And art is the word encompassed by that. So we have ART for our final blank. Now that we've filled in all of the letters, it's time to solve the puzzle. What did the toothless old termite say when he entered a tavern? We have is, the, and bar or bartender. I guess you could go either way, but we'll say bartender here. So, I mean, it's a tavern, so is there a bartender here? But he's a termite, so he's asking, is the bar tender here? Is it like a nice juicy steak? Because he eats wood. Anyway, Mr. Sutton signing off.